The discovery that proves scientists wrong. Scientific theories are the cornerstone of success and future development in all fields of life, be it how the theory of relativity changed how modern physics is seen, or the theory of evolution that has tried to explain life's origin. However, all theories are not successful, and sometimes, even though they seem promising at first, they fail in the long run. Scientists have to go through considerable obstacles to prove their theories. Hence, we should be even more cognizant of the achievements of these brilliant and inquisitive minds that are trying to help humanity. With that being said, it is also valuable and interesting to look at the theories that ultimately ended up being disproved. Let's dive deep into some of the most famous theories that were later debunked. Number 1. The expanding or growing Earth theory. The theory that the Earth is expanding has now become pseudoscience. Once a theory that many scientists accepted, it is now fully disproven. In the past, due to the limited amount of knowledge and data we have about geology, it was hard to explain the changing terrain. Charles Darwin was one of such individuals that perpetrated the idea of an expansion in volume and mass of the Earth on a large scale after he observed beaches in South America. Others attributed the expansion to the constant addition of matter in the universe, as they believed that planets could change their dimensions. However, after the introduction of the plate tectonics theory, which explained the geological changes throughout the Earth, the theory of an expanding Earth fell flat on its face. New equipment that accurately measured the Earth's volume and area correct to millimeters proved that Earth was not expanding. In fact, data and analysis from the past confirmed that Earth had not gone through any significant expansion in the past 600 million years. Number 2. Luminiferous ether. Before Einstein's theory of relativity, the concept of light differed significantly from how we perceive it today. Most people believe that there is a luminiferous ether that enables light to flow through it. Many scientists came up with equations to prove this, and some even tried to prove it through experiments. The most famous example of proving the existence of the ether is one. Theoretically speaking, the existence of an ether would result in a differing speed of lights that would hit the detectors at different time intervals. Later, Einstein, through his theory of relativity, would completely debunk the existence of a luminiferous ether. 3. Einstein's flowing stance on static universe. While we have learned that Einstein contributed to rendering some theories obsolete, he was not prone to making mistakes himself. After completing his theory of relativity, Einstein worked on applying the principles of gravity in the universe. For this purpose, he had to create an equation that would obey the laws of physics. Einstein considered the universe as a whole. However, he assumed that the universe was a finite space and was static in time. Because of his assumption, which is said to have been Einstein's biggest blunder, Einstein had to come up with a constant that would apply to a finite universe. This came in the form of the cosmological constant. Without getting into the nitty-gritty, the cosmological constant was just one way to balance out the effect of gravity. However, soon enough, Einstein had to give up his idea of a stationary universe and subsequently his cosmological constant in his field of equations as well. This was mainly due to Edwin Hubble's discovery of the relationship between redshifts of galaxies and their distance. This discovery disproved the notion of a static universe, and Einstein accepted it soon after. Number 4. Fleischmann. Ponce nuclear fusion. Nuclear fusion is a reaction that happens frequently and naturally in the Sun and other high-temperature stars. The reason that it is not possible on Earth is precisely because of the high temperature. You would need absurdly high temperatures, as a lot of energy is required in order to overcome the forced repulsion between positively charged nuclei. Considering this, if someone were somehow able to cause a fusion reaction under normal conditions involving lower temperature, it would be the breakthrough of the century. One such theory emerged when Stanley Ponce and Martin Fleischmann announced that they have successfully completed a nuclear fusion reaction under room temperature. Their experiments were based on the fact that heavy water's usage in the electrolysis of salt solution could allow for fusion. It would do so by making deuterium atoms absorb into palladium electrodes at high density, causing their nuclei to merge. This would theoretically produce energy, neutron and gamma ray emissions, proving that fusion has taken place. March 1989 became a chaotic time as this discovery sent the scientific world into a frenzy. Multiple scientists at the time tested the theory, and in the following weeks it was called out on its flaws. Many reputable scientists at the time wrote extensive critiques about Fleischmann and Pond's work, even calling them frauds. Soon enough, other experimentations were done which also disproved any notion of fusion at room temperature practically. Number 5. Planet Vulcan. A blessing in disguise. The planet Vulcan was said to have existed next to Mercury and was confirmed in 1859 by Urbain Le Verrier. Scientifically speaking, it made sense for the planet to be present next to Mercury as well. The reason for that is rooted into Newton's law of gravity. If you believed in Newton's theories, which was very likely at that time, you would assume that some other planet caused Mercury's wobble. This led to consensus belief that Vulcan existed, and there were very few doubts about it. In fact, the same principle led to the discovery of Neptune after observing the wobble of Uranus. With credible sources like Leverrier claiming Vulcan's existence backed up by other people that swore they saw it on their telescopes left little doubt that there was a new planet in our solar system. Enter Albert Einstein once again, who was on the verge of proving his theory of relativity. However, to prove his theory accurately and convincingly, he had to disprove the existence of Vulcan. This was seen as an impossible task, as Vulcan's existence was already set in stone and accepted in the scientific world. However, when Einstein correctly predicted the orbit of Mercury using general relativity, he proved that there was a more profound way in which we have to look at gravity. By disproving Vulcan, Einstein not only gave more credibility to his own theory, but showed the world that space-time was not static. Only through his lens, Mercury's wobble could be explained without the existence of another planet nearby. Number 6. Spontaneous or equivocal generation theory. The theory of spontaneous generation of life had existed far more than 1,000 years before it was disproven. The earliest record of the idea of spontaneous generation goes back to Aristotle when he claimed that life could appear out of nothingness as long as there was a vital heat present in non-living material. What Aristotle meant to say was that living things could appear out of nothingness given that there is an environment that can house them. Examples of frogs being present out of nowhere after flooding occurred, or fish rapidly colonizing a pond where there were no signs of them before, are some examples of spontaneous generation. Even though today this theory seems bogus, it had credibility even throughout the 18th century. In fact, some scientists also came up with experiments to prove the theory. John Needham's experiments in 1745 were one of the many that were conducted to test the theory of spontaneous generation. He took some animal and plant matter, infused it into a broth, and then boiled it, hoping to eliminate all microbes. After doing so, he isolated the broth and sealed it into a flask. When he later observed it, microbes were present inside the broth, confirming the theory of spontaneous generation. However, scientists today believe that this was simply because he might not have boiled the broth properly. It wasn't until Louis Pasteur came along with that this theory was decisively disproven. In 1858, Pasteur proved that airborne microorganisms were responsible for the life force that existed even without the introduction of animal or plant matter. Pasteur's theory was confirmed by his experiments where he did not allow airborne particles to come into contact with his sterilized broth using special flasks. At the end of the experiment, no such life force was detected in the broth inside his special flask, and he walked away with an award for disproving spontaneous generation.